Hi everyone. So this is our second class on the topic metals. Okay, the metals is a chapter under workshop calculation and science in CATS. Okay, so first word we are last video we discussed the first part of this video. So what is the properties, physical properties, mechanical properties, and types ferrous, non-ferrous. Okay, and also of iron, and then what is the chemical formula of different ore, then how it is obtained from ore, like that calcination and working of in the blast furnace. Today we have to discuss the first we have to discuss classification of iron. Okay, so there is a mainly four classification is there. One is pig iron, then second one is uh, cast iron, and third one is wrought iron, and fourth one is steel. So iron is classified as four. One is pig iron, second one is cast iron, and third one is wrought iron, and the fourth one is steel. So what is a pig iron? So the it is iron obtained from blast furnace. So we are already discussed the about the blast furnace. So when you are getting the one iron from the blast furnace, that is known as pig iron. So this process of reduction of the iron or to pig iron is known as smelting. That process in the blast furnace, it is known as a smelting. So which process you will get the pig iron, it is known as a smelting. So the iron obtained from the blast furnace is the pig iron. This process is known as a smelting. So what is the use of the pig iron? Refined and remelted and used to produce other variation varieties of iron and steel. So it is refined. So pig iron is refined and remelted and used to produce other varieties of iron and steel. So other varieties of iron and steel we are making using this pig iron. Okay. So iron obtained from the blast furnace, it is known as a pig iron. That is the first important point. The second one is this process is known as a smelting. And the second type of iron is known as cast iron. So it is cast iron is made from pig iron. So it is a process is during in the furnace is known as cupola furnace. This refining is carried out in the cupola furnace, which is a small form of blast furnace. So cast iron we are getting from the pig iron through the process is known as cupola furnace. So cupola furnace you will get the cast iron. Okay, from the blast furnace you will get the pig iron, and from the cupola furnace you will get the cast iron. So cast iron is an alloy of iron, carbon, and silicon. So cast iron is the alloy of carbon, iron, and silicon. This carbon content is ranged from 2 to 4%. So higher percentage of carbon is contained in the cast iron. Okay, there's another point. Higher component of higher percentage of carbon is contained in the cast iron. It is ranged to 2 to 4%. Okay, so from the one important point two is one two important point is this. One is the cast iron you are getting from the cupola furnace, and the second one is the carbon content range from 2 to 4%. Okay, then again the cast iron. So there is a mainly four iron is there: pig iron, cast iron, wrought iron, steel iron. In the pig iron and cast iron, then cast iron again classified into four. There is a four types is there. One is gray cast iron, second one is white cast iron, and the third one is malleable cast iron, and the fourth one is nodular cast iron. So what is a gray cast iron? So it is soft and brown color. Okay, because of it is graphite, so it is contain graphite content. Okay, so I cast which cast iron contain graphite means it is a gray cast iron. Cast iron provides an excellent bearing and sliding surface. Because of it is graphite content, cast iron provides an excellent bearing and sliding surface. Okay, so gray cast iron contain graphite. Okay, this widely used for the casting of machinery parts and can be machined easily. Okay, earring and sliding surface. Okay, the next one is the melting point. So melting point is 1200 degrees Celsius. So melting point of gray casting is 1200 degrees Celsius. Gray cast iron is widely used for machine tools because of its ability to reduce vibration and minimize tool chatter. So gray cast iron is widely used for machine tools because of its ability to reduce the vibration and minimize the tool chatter. Okay, so gray cast iron is contain graphite. It is mainly used for the machine tools, and the melting point is 1200. Is an very important point. The second one is white cast iron. So it is a very hard type of a cast iron. It is used in component which should be abrasion resistance. So it should be abrasion resistance. There is the component we are using white cast iron. So it is a very hard. So it is component which should be abrasion resistance. That area, that component we are using white cast iron. White cast iron is produced by lowering the silicon content and by rapid cooling. So it is a white cast iron is produced by lowering the silicon content. You are reduce the silicon content and by rapid cooling, and then rapid cooling. So it is also known as chilled cast iron. So one important point is there. Which one is a chilled cast iron? It is a white cast iron. Which cast iron contain graphite? It is known as a gray cast iron. Okay. And the third one is malleable cast iron. So malleable cast iron has increased ductility, tensile strength, and toughness when compared with the gray cast iron. So when compared to other cast iron, the malleable cast iron has a increased ductility is there, tensile is increased, tensile strength is there, and toughness will be there. So malleable cast iron is produced from white cast iron by prolonged heat treatment. So when the malleable cast iron is heated, okay, prolonged heat treatment lasting for 30 about 30 hour. So 30 hour we are making we are prolonged heat treatment on the white cast iron. You will get the malleable cast iron. Okay. Then the fourth and last one is the nodular cast iron. This is a very similar to malleable cast iron, but this is produced without any heat treatment. So it is not produced by any treatment. You know, the malleable iron is heat produced by the heat treatment on the white cast iron. So nodular cast iron is also known as nodular iron, ductile iron, or spheroidal graphite iron. So there is a three another nodular iron or ductile iron or spheroidal graphite iron. Okay, this has a good machinability, castability, resistance to wear, and the low melting point and hardness. There is a specification. So cast iron, there is a specification of the nodular cast iron. This one is good machinability, castability, resistance to wear, low melting point, hardness. Okay. Malleable and nodular casting are used for machine parts where there is a higher tensile stress and moderate impact loading. So where you need higher tensile strength and moderate impact loading, you are using malleable and nodular cast iron. Okay. So the third classification of iron is the one is wrought iron. Okay. So wrought iron is a purest form of iron. So first one is a very important point. Which one is the purest form of iron? It is a wrought iron. The analysis of wrought iron shows that much of 99.9 percentage of iron. So wrought iron containing 99.9 percentage of iron. So it's a purest form of iron. When it is heated, wrought irons does not melt but only become pasty, and in this form it can be forged into any shape. So when you are heating, it is not will melt, it will be become a paste form, and you can easily forge it into any shape. Okay, so modern method used to produce wrought iron is the putling process and or Aston or bias process. So second important point, in the wrought iron there is two important point is there. One is it is a purest form of iron. So which is a purest form of iron? It is a wrought iron. The second one is which method is used to produce the wrought iron? One is putling process, and the second one is Aston or bias process. Okay, and the next one is the classification of iron is steel. So steel carbon, in the steel carbon content is varies from 0.15 percentage to 1.5 percentage. So carbon percentage is varied from 0.15 percentage to 1.5 percentage. Beside there are other impurities like sulfur, phosphor. It is containing sulfur, phosphor like impurities. These are hardened and tampered by heating to a definite temperature and cooling it in oil or water. So these are hardened. So steel is hardened and tampered by heating it to a definite temperature, to a particular temperature, and cooling it in oil. So you have to cool it in oil or water. So it could not in air. You have to cool in oil or water. Okay, so the next we have to uh, study about the, there is a 6 important method you are making for making the steel. So it is a process name, it is an important in anywhere. So you know that blast furnace you will get the pig iron, cupola furnace you will get the uh, cast iron. Okay, then next one you are already said wrought iron. Wrought iron you are getting the puddling process and or Aston or bio process you will get the wrought iron. And then steel iron you are getting from the, there is a mainly 6 processes there. One is cementation process, crucible process, Bessemer process, open hearth process, electrothermo process, high frequency process. So the process name is important. Blast furnace process, cupola furnace, puddling furnace, Byers process. Okay, sorry, puddling method, Byers furnace, like that. It is an important like that. Cementation process in the steel, it is a cementation process is the crucible process, Bessemer process, open hearth for process, electrothermo process, high frequency process. Okay, so then again we are classifying the steel. There is a two type of, mainly there is a two type of steel is there. One is plain steel, other one is alloy steel. So plain steel, or the second one is alloy steel. So what is a plain steel? Okay, so again we are classifying, we are making classification on the plain steel. So according to the percentage of carbon, plain steel is the following 3 type. One is low carbon steel, medium carbon steel, high carbon steel. This classification is important, normally asking in the exam. Okay, low carbon steel, medium carbon steel, high carbon steel. So what is a low carbon steel? It is also called mild steel. So low carbon steel is also known as mild steel. So you are familiar with mild steel. So mild steel ka another name kya hai? Is a low carbon steel. So what is the percentage of carbon? So it is a bold letter. You can see 0.15 to 0.25 percentage. So carbon percentage is 0.15 percentage to 0.25% in the low carbon steel or mild steel. So okay, the next one, due to less quantity of carbon is sufficiently soft and it tolerates the strain. So it is a less quantity of carbon, so it is a sufficiently soft and it tolerates the strain. Okay, it can be put in different shape through forging and rolling. So through the true process is there, one is forging, other one is rolling. Through these two processes you can make into the different shape. Okay, this is not very hard and strong, it is not very hard, so carbon content is very low. This cannot be hardened or tampered by ordinary method. Okay, this cannot be hardened or tampered by ordinary method. So where we are using nuts, bolts, rivets, sheet, wire, T-iron and angle iron are made out of it. So low carbon steel, so it is a carbon percentage 0.15 to 0.25 percentage, is also known as mild steel. And we are, where we are using it is nuts, bolts, we are making use etc, we are making the low carbon steel. The second one is medium carbon steel. So what is the carbon content? It is 0.25 percentage to 0.5 percentage. Okay, 0.25 percentage to 0.5 percent is a medium carbon steel. Due to the excess of carbon, it is harder and tougher than mild steel. So carbon content is more compared to the mild steel. Okay, so it is a harder and tougher. The tenacity is more. These used to harden or these used to harden or tampered. So it is a tenacity of this medium carbon is more. Okay, various things are made by forging, and so you can make various things by using the process forging and rolling. This is used for making high tensile tube, wires, agriculture implements, connecting rods, camshaft, spanners, pulleys. Like this is an example. So we are this type of material. So camshaft, spanners, pulleys, like we are using the medium carbon steel. Okay, the next one is high carbon steel. So what is the carbon content from in the carbon content in the high carbon steel? It is 0.5 to 1.5 percent. So first class we 0.15 to 0.25. It is the low carbon steel. Okay, 0.25 to 0.5 it is a medium carbon steel. 0.5 to 1.5 it is high carbon steel. It is very hard and wears least. It's a very hard and wear is a very least wear. Okay, this can be hardened by heat treatment. You can heat this hard carbon steel. You can become hardened. Okay, this can neither be cast or rolled. So it cannot be neither be cast nor rolled. You cannot do cast and rolling. Okay, casting and rolling. Okay, this is very hard and tough. Okay, so carbon content is more, so it will be hard and tough. It occurs permanent magnetic properties. So high carbon steel acquire permanent magnetic properties. Okay, it will be acquire permanent magnetic properties. This is used for making the point tools, spring, pumps, files, cutleries, cold chisels, press like. So high carbon steel we are making for mainly cold chisel, files, pumps, spring we are making using the high carbon steel. So next classification, alloy steel. So first we are there is a medium steel we are classified into the plain steel and alloy steel. Plain steel we are again classified into three type of steel: low carbon, medium, and high carbon. Then alloy steel. When the steel is mixed with the other metal like vanadium, manganese, tungsten, manganese or tungsten, it is known as a alloy steel. So alloy steel again classified into the two type. One is low alloy steel and other one is a high alloy steel. So what is a low alloy steel? Beside the carbon, other metal are in lesser quantity. So beside the carbon, so another some other metals also added to the iron. So it is a so it is tensile strength will be more. Okay, the welding can work on. You can do welding on this low alloy steel. This can also be hardened and tempered. Okay, it can be hardened, make hardened or tempered. It is used for manufacturing various part of aeroplane and camshaft. So aeroplane and camshaft we are making low alloy steel we are using. Okay, high alloy steel. What is a high alloy steel? Beside the carbon, it has a high percentage of metal higher than the low steel alloy. So it is a low steel alloy. It contains some other metals. So it is a small quantity. In the high alloy steel means higher percentage of iron other metal will be included in the steel. Okay. So types there is a high alloy steel again classified into the seven type. One is high speed steel, nickel steel, vanadium steel, manganese steel, stainless steel, silicon steel, cobalt steel. Okay, I think stainless steel is you're familiar with stainless steel. So what is a high speed steel? It is also called high tungsten alloy steel because of it has more quantity of tungsten. So it is high speed steel known as high tungsten steel because it containing more percentage of tungsten. So there is a three type of high speed steel is there. One is tungsten is 22 percentage, chromium 4, vanadium 1. Here will be tungsten 18 percentage. Here will be tungsten 14 percentage. Chromium and vanadium is a 4 percentage and 1 percentage respectively. So cutting tools are made out of it because it is very hard and became soft at a low critical temperature. Due to this property, it is because very hard and became soft at low critical temperature. You can use as a cutting tool. That is high speed tool. Okay, but due to the high percentage of tungsten, it keeps working up to high temperature. You can working at a high temperature. It is possible because high percentage of the tungsten. Okay, it is used for cutting tools, drilling, cutter, reamers, hacksaw blades that we are making the using high speed steel. Okay, next one is nickel steel. In this 0.3% of carbon and 0.25 to 0.035 percentage nickel is present. Okay, 0.3 percentage carbon and 0.25 to 0.35 nickel is present. Due to the nickel, it is tensile strength, elastic limit, and hardness is increased. So when you're adding the nickel, tensile strength, elastic limit, and hardness will be increased. So another important way, it does not catch rust. So nickel steel does not catch any rust. Okay, it is a cutting resistance increases. It is cutting resistance increases 6 times more than the plain carbon and steel due to 0.3% of nickel. So it is a cutting resistance will be increased to 6 times when you're adding the nickel. Okay, this is used for making rivets, pipes, axle shift shafting parts. Okay, axial and shafting parts of parts of buses and aeroplanes. So it is making rivets, pipes, axial, shafting parts of buses and aeroplane. We are making the nickel steel. If 5% of cobalt is mixed with the 30 to 35% of nickel, it became invar steel. So when your 5% of cobalt is mixed with the 30 to 35% of nickel, it becomes invar steel. It is mainly used for making precious instruments. Is another point. So when you're adding cobalt to the nickel, it became invar steel. Okay, then again the next classification is a vanadium steel. So it contains 1.5% of carbon, 12.5% of tungsten, 4.5% of chromium, 5% of vanadium, and 5% of cobalt. It is elastic limit, tensile strength, and ductility is more. Vanadium steel ka elastic limit, tensile strength, and ductility is a more. It has a strength to bear sharp jerks. Okay, sharp jerks, to bear the sharp jerks. Okay, it is mainly used to manufacture of tools. Okay, vanadium steel is mainly used for manufacture tools. Next one is manganese steel. So it is also a special high alloy steel. It contains 1.6 to 1.9% of manganese and 0.4 to 0.5% of carbon. It is hard and less wear. It is not affected by a magnet. It is not affected by a magnet. It is used to grinder and rail point. Grinder and rail point, we are using the manganese steel. Okay, it is a less wear, so we are using in the grinder. The next one is important, stainless steel. Along with the carbon, it contains 0.2 to 90.6% of carbon, 12 to 18% of chromium, 8% of nickel, and 2% of molybdenum. It is used for making knives, scissors, utensil, parts of airplane, wires, pipes, and gears. That we are using the stainless steel. So there is a 8 important property of stainless steel. Is there one is high corrosion resistance, higher cryogenic toughness, higher work hardening rate, higher hot strength, higher ductility, higher strength and hardness, more attractive appearance, and lower maintenance. Okay, higher corrosion resistance, higher cryogenic toughness, higher work hardening rate, higher hot strength, higher ductility, higher strength and hardness, more attractive appearance, and lower maintenance. The next one is steel, silicon steel. So it contains 14% of silicon. It uses are multiferous according to the percentage of silicon. It uses are multiferous according to the percentage of silicon. Okay. 0.5 to 1% of silicon, 0.7 to 0.95 percentage of manganese mixture is used for the construction work. In the construction work, silicon will be 0.5 to 1% and 0.7 to 0.95% of manganese. Okay, 2.5 to 4% of silicon content mixture is used for managed electric motor generator lamination of transformer, that we are using in the silicon steel. So silicon steel mein silicon content is 2.5 to 4 percentage. Okay, silicon steel mein the 2.5 to 4% of silicon will be there. It is used for the electric motor generator like that. The chemical industries 14% silicon content is mixture is 14% silicon content mixture is used. Okay, the next one, last one is cobalt steel. Okay, is high carbon steel contains 5 to 35% of cobalt. So 5 to 35% of cobalt. Toughness and tenacity is high. It has a magnetic property, therefore used for permanent magnet. So use for the permanent magnet, we are using the cobalt steel. So here we are studying some of many types of irons and classification irons, classification of steels like that. Okay, so it is important. Here is a percentage of carbon. It is an important, and the many process you are study blast furnace, cupola furnace. Okay, like that. The simmer process like that is also important. Okay, so these are next we have to discuss the non-ferrous. So non-ferrous metals. Okay, so two video we are discuss the ferrous metal. Next we have to discuss the non-ferrous metals. Okay. So I'm going to stop this class. Thank you.